Let me try using the microphone. Hopefully it's not echoey. All right. So as you have downloaded the notes and the assignments, let's share screen real quick. So this week, we're going to have to dive a little deeper into thinking about troubleshooting and looking at configuration for your network adapter. Because starting next week, I think next week, we're going to do a little bit of network sniffer. So we'll take a look at the traffic coming through as packets. And then you are going to start configuring static IP down the line, especially when you're configuring servers. So it's kind of important to know what devices is doing what, right? I know this might be review from CIS40A or another class, but it's always good to kind of be familiar with these components and systems. So the first part of the notes, it talks about network interface card, which is your network adapter that you use to connect your Ethernet cable from your computer to a network device, right? Like your router or your switch. So its job is to be able to take your data, make sure that it prepares your data and it converts that into bits, 0 and 1s. And it transmit on your wire, which is what you saw when you made your Ethernet cable, each of the copper wire, right, the twisted pair, and be able to send. Remember that your computer is an integrated circuit. It's made of many different types of circuits on the boards, on the adapter, on the components. Everything's transmitted, even its data, large or small, is in electrical signal, right? So it sends it through. If you're connecting via the Ethernet, or if you're using wireless adapters, which is the same, right? It's just in the wave format over the air. So the adapter, it would look like this. The one on the right is for like a PC, right? As you look at this, this is where we would connect it to the motherboard, right? Normally now we would use PCI Express, which is a path or a connection point on the motherboard to be able to transmit. It's called bus. So a bus is simply a data pathway where we can connect a component, and that component would be able to transmit data through the motherboard or receive data from the motherboard, right? And so on. So what we would see is the adapter would look like this, right? On the left side, you would see how this one has 2 Ethernet connection. So on a normal server motherboard, you would see that it would have multiple Ethernet connection because the server, its job is to provide services for many systems. So you would see that it would have multiple adapter option, or it would have one adapter that has many ports. And on this one, it's integrated with the motherboard. So this is what you would see. Now, when you configure your server, you're going to see that there's an option down the line that you can team the NIC together so that way we can use it for a certain functionality. So if I make this server into a web server, right, I'm going to receive a lot of web requests from maybe thousands or even millions of systems, right? So I want to be able to make sure that I would manage these to be able to handle incoming and outgoing, right? The request that's coming in and the response that's going to the system. So this is what you would see. Now for your assignments, and again, you don't have to put verbatim, you can summarize it, right? The functionality of a network interface card or your NIC, NIC, is basically it's responsible for preparing your data, right? Like I said, large or small, whether you have a very large movie or an image or a small file. So that way it can transport it. So it preps that, and it would, like we talked about encapsulation before. So at the physical layer, it needs to prepare your data and break it down into 0 and 1s, right? So that way it can transfer your data over the electrical wire, right, through the motherboard bus or the system bus. And through that, that, we would see that it travels through the cable and ultimately the larger network, right, as electrical signal. So if you're looking at any form of network, mobile networks, right, or our physical network, you would see that all your data is then being prepped by your network adapter, whether it is wireless or it's wired. So ultimately, everything is transmitted in 0 and 1s, and the functionality of the adapter is to be able to prepare it and transmit it. And remember that we have to be able to make sure that the data is understood, right, by the system. And this is when we're thinking about like protocols and services. So I'll tell them to fix that. Okay, so now if we are requesting a website, right, we would go through all the 7 layers like what we talked about before. But at the physical layer, this is what you see with the network interface and the electrical signal for network communication. The second part of your notes, it talks about the transceiver, right? Transceivers is mostly used now in network appliances like a switch, right? Or network communication systems. Back in the day, transceivers were more common in your consumer PC or computer. Now we use it mostly for network communication purposes. So sometimes you would see that we would add a transceiver to a switch. So I was at the conference with Patricia and the rest of the Mesa and SM students last week, right? And I was sitting in on a Broadcom presentation, and they were talking about how they built these processors to transmit at terabyte per second, which is a lot faster than what you see in your regular Ethernet network, right? But to handle AI systems, right? So now that we have AI integration, the input, the throughput for data across the network at their data center, you know how when you're using ChatGPT, right, or you're using some form of AI, it has to give you appropriate response in a quick manner, right? So they have to have the network devices. So they talk about transceivers, they talk about the switches with powerful processor to be able to accommodate AI integration in a data center. So now you would see 2 types of transceiver. One is going to be on board. That means that it's built onto the motherboard, right? It's built with the motherboard, okay? And it would also integrate with the interface card, the network adapter. So if you buy a motherboard now, likely that you would see that your network interface card is incorporated with the motherboard, right? If you're building a computer. You would also see that if you buy a network interface card on its own, if you have an onboard transceiver, it would have the transceiver component added to it. This is what we saw a lot in the 90s and early 2000s for the consumer PC. So onboard, simply that it is built with the adapter or with the actual motherboard. The external transceiver is an actual separate component that adapts to the system. So that means that you buy that component externally, right? And then you would plug that component to a switch, right? A router, a system that you need to be able to transceive, right? Or receive and send information. So a lot of the time you would see that it's used with a switch or a router. And you don't have to give it instruction on specific port of the device. It would already been programmed to be able to adapt to an existing system so that it works. So if you look at the notes, right, it gives you like a picture of the transceiver. So this is what you would see as it would be built in with the adapter, right? This particular connection. This is like for the old coaxial, right? For the thin net. Sometimes you will see that it uses the serial connection, which is serial is like 1 bit at a time. So let's think about if you need to gather water in a bucket, and if you collect 1 drop at a time, right, that takes a long time to fill up. But if you want something that's parallel, that's faster, that's going to be able to transmit. So if I'm able to gather the water, and if I can gather 16 drops of water each, seconds, that's going to take me a lot quicker to fill the bucket versus 1 drop per second, right? So you really have to think about the media that you use, how that transceiver is integrated, the type of cable that you use with it, right? That's really important for your network throughput. And then the external, it would look like this. So nowadays, you're going to see something like this, okay? To be integrated. And Broadcom was talking about, we're still dependent on Ethernet, right? But the Ethernet is ultra Ethernet. It's not just your regular Ethernet that you would see at, 1,000 gigabit per second or 1 gigabit per second. For AI, we are boosting it. Ultimately, they're using different type of cable, and they're using different type of components that's able to receive faster, right? It's still going to be bits, right? But the transceiver that you attach it would be like this. So you would be able to adapt this, connect this into a switch or a router. So this is an external. Any question? So if you go into a network environment, you talk to administrator or the technician, right? You often see that they would adapt transceiver in this type. Your SFP, right? QSFP. So they're all different type, but ultimately, these standards actually give you different rate of transfer, right? So ultimately, it gives you higher speed as you select like specific ones that is more modern. Okay. Any question? All right, question 3. When troubleshooting network interface card that has multiple type of connectors, what should you do? You saw one of the adapter has like different type of connector, right? We want to make sure that the configuration, the setting, right, on the software level is set to auto, right? So on your operating system, like Windows 10 or 11, or the Windows Server, right, making sure that you check the network adapter configuration, the setting needs to be set to auto, because you are having multiple connector. If you only select one connector, right, you're not utilizing the multiple options that it comes with. So when we set it on auto, it can use, 1 out of the 3, 2, so it can switch to different connection type, right? And if you have the cable connected to those, you're able to transmit in multiple ways. So that would be easier. So making sure that we are on auto. Okay. So if it's not communicating, we can go into the configuration, the setting for your adapter. We'll look at that today for the lab to make sure that you set it on auto. And this is more often with server environment, right? Or network appliances versus your Windows PC or your client system. So where can I find the answer for 3, right? You would go down to the section right after transceiver on page 3. It goes in depth and it talks about set it on auto to detect, right? And then if you have auto configuration, by default, it should be, but we always want to go look at the properties and check. And in Windows environment, you can always go to device manager, right? Search for device manager. We'll see that today. Right click your adapter, and then you can go to the properties to be able to see that. Now, in some system, you don't have right? Device manager, right? You only have command prompt and you have or PowerShell. So we'll take a look at PowerShell option today to how to view your network adapter and its state. Okay, so let's talk about your transmission. I think I briefly touched on this in the last couple of weeks. We will revisit this term over and over again because ultimately communication in general breaks down to these methods. Okay? So question 4, it says explain the types of transmission methods of a network adapter. Which methods provide, there's a grammatical error, the highest throughput rate. So you would have the first option would be simplex. And this is a one-way communication only. It's only one direction. The system can send or receive in a simplex method or mode. Okay. And when you look at the property sheet today, you do have some option with how your network adapter communicate. All our network adapter today, right, by default, we don't use simplex, but you do have specific communication system that would only send. There are devices in the network that would only broadcast. It sends to everybody, but it doesn't listen. It's like you're in your car listening to the radio. You know, you can hear them, but they don't hear you, right? That's one direction. It's a simplex. Okay. Now, the second option or the second method would be a half duplex. So it would allow both directions, but it can only do one at a time. So the system can either send or receive. It won't do both at the same time, right? It's able to do send and receive, but it can only do send or receive, right? So that means that if I'm setting my switch to a half duplex, it can only either send to communicate with other switches, or it can only receive data from the other switches, okay? So if you set it to half duplex, it can do either or. It's capable of doing either or. Okay. Send or receive at the time. Now, by default, your network adapter or your wireless adapter is full duplex. That means that it allows both direction at the same time. It can send or receive. This is how your system would be able to have multiple functionality when it communicates. For example, right, I can chat with my friend while playing game, right, and download at the same time because you have to submit requests and receive response at the same time. So by default, we are using full duplex. Let's move this up a little. So the full duplex allows the communication in both directions at the same time. It's capable of send and receive together. So out of all of these three, full duplex, of course, is going to give you the highest throughput, the highest rate in communication. So if you want performance, if you want high response rate, if you want system communication that would be fast, we want to make sure that it is full duplex. Now, not always, like I said, in the case in our network environment, there's devices that are really made for specific things, right? It can either send, it can send or receive, and then sometimes we want it to act a certain way. But in general, if you're looking at a client system like Windows PC or your workstation, it is a full duplex. Any question? So I have the pre-recorded videos, my lecture from prior there, right? And I'll upload the current one after tonight, maybe tomorrow. And I know Friday I already lectured on this. So if you have my playlist, you already saw the Friday session, which is I gave them the time to do cable first, which takes up 30 minutes, but or an hour, but I want to do this so give you cable time at the end. So that way we can streamline some process here. Any question? So for final and quiz in this class, make sure you know simplex, half duplex, and full duplex. We'll come back to this when we talk about switch technology and some of the other technologies, right? All communication devices would come back to these methods. So understanding this is going to help you down the line. You're like, oh, that system is broadcasting, right? Sometimes we have broadcast storm in the network, right? There's one system that sends to everybody, and sometimes that can cause issue. So, or sometimes it will be looping. So we'll talk about that. Okay, what I'll do is I'll move 5 up a little and 6. Okay, so for 5, it says, how can you determine what manufacturer produced your network adapter that is installed on your computer? So all manufacturer for network adapter, they're given a range of MAC addresses to use, okay? And when they produce the adapter, before they sell it, they will program in individually each of the MAC address, the media access controller address, the physical address to each adapter, okay? Now we can pinpoint who sold that particular adapter by finding the MAC address of the system, and the value in the front of that MAC address is going to really tell you the vendor, the creator, right, for that particular device. Okay. Why is this important? Well, sometimes you have to find out which system that is, right? For example, you have an attacker, right? They're able to get inside your network and you are responding to the incident. You have to, so based on your SIEM system and your network monitoring system, you're able to find that traffic and that system information, right? Remember that all systems communicated in all 7 layers, right? MAC address is at layer 2, because this is where we would see the physical address, so that way it will prepare the data and the data header, so that way it can transmit across. So if they come in and they're downloading files, they're accessing systems, they are changing credential, etc., right? We would be able to follow it. Now we can follow the actual physical address to really find that system. And MAC is also a way that we can secure the network by filtering out the system that we don't want. So sometimes you have to pinpoint who that is, right? Which adapter that is, because that's not part of your network and somehow they would get in. So we will be able to find the information for the vendor. Now, a lot of you probably took ethical hacking or security class and you said MAC can be spoofed, right? But you have to remember that every time that you take on an address that's allowed in a network, right? Because it is pertaining to a switch. So when we set up security on a switch, we would allow specific address to be used in that segment. So for example, you know how you have a student ID? Your student ID is used at RCCD only, right? You can't go to Chafee and use your student ID. So it's like setting up all the ID for the systems that's allowed, and then anything that's outside of that, we're gonna block, okay? So an attacker, they have to take on a known ID, right? A known address for a system to be able to access that part of the network. And if they go to different part of the network, they have to keep doing that, right? So spoofing, you can use technologies, tools, and software to be able to do that. However, right, you have to really understand the network to get through the network. That's my point. Yes.
So like not filtering with
It is a security measure, yes. That is MAC filtering is talking about.
but that's better than just having the MAC address.
Yeah, so I would take the MAC address and I will tie it to a port. So for example, your system has MAC address to say A, B, C, D, E, right? And that will be port 1 on that switch, or port 5 on that switch. So on the switch table, I would specify that this system with this address is correlated with this port connection, which is where you plug in your cable. Port 5 on this switch, right? So if someone with a different MAC address plug into your port, it's gonna reject. Okay, that's how filter works. So we filter based on address and port. Now, if let's say that I don't do it carefully, right? Someone is able to plug into a port, then I have to investigate and find out where did that MAC address comes from, right? You can start with the switch table and you can narrow down to what, because every time that you connect, the switch keeps a record of it. It adds it to a table as an entry. It's going to say this system is now connected in this segment, this address to this port. Okay. So they have to go in and they have to tweak the table. That's how they get through.
So you use the MAC table. Let's say you just connect to you know where that was coming from. This gets back towards in that table.
Yeah, so your switch always update everything that's connected, right? So if they have access to your table, they can modify your table. They're on the switch. But if they don't, right, your security system should the NIDS, it should pick it up and it should say, hey, there's unknown device, right? That's should be rejected here in this segment. This is why you should have an NIDS inside. Understand? Okay. Sorry, I kind of branch off and go into 27 a little bit, but I want you to see the big picture of why we're learning these things, right? It comes back to how we can secure these things. Okay, so when you troubleshooting a network adapter, a few things that needs to happen. I always follow these two rules. First, check your hardware. Second, check your software. Meaning that you would start with looking at the cable and the link light. Okay, is the cable connected, right? And do you have any kind of link with the link light? Okay, so check your physical connection. That's the hardware piece. Once you verify that, then you need to go to the software, your OS. You need to check your configuration, check an IP address. How do I do that? Right, we talked about this before when we did the topology. Open up command prompt, right? Type in for Windows IP config, one word. If you are using a Linux system, right? Let's say you're managing a Linux server, IP space address on CLI, right? And making sure, we'll talk about IP address in the next few weeks, making sure that we have a valid network IP address. That means that it obtained an IP address, so it should be connected to the network. If you are not having a valid IP address, restart the system to see if it will renew the IP address. You can force it to renew through command prompt, and we'll do that later, okay? You can also ping. So if I do a loopback address, so I'm going to do that here, right? CMD, open up my command prompt, and I talk about IP config earlier. Now to find the MAC address, you can do IP config /all where you get all the configuration. But if you just want an IP address, you just simply do that, right? So here is my IP address for the network. And then if I do an all, I would get a physical address, which is this right here. That's your MAC address, right? Now, some systems, some software would use a colon instead of a hyphen, the dash. And so that's common, but it is a hexadecimal system, right? And it's given. So now if if I want to ping my system, so let's check my IP. So my IP is, you see the default gateway, that's your router right here, right? It's always going to be a .1 because that's the first system that you see coming in from the internet or an external network, right? And then there's some server information. We'll come back to those things down the line. But I'm given an IP address, and this is my IP address right here. So what I can do is I can ping it 10.111.66.212. And if the system is connected, it should reply, right? In Windows environment, it's going to send out 4 requests. It's going to say, are you connected? Yes, right? Are you connected? So 4 times. In Linux, it will continue to request until you tell it to stop, or you can specify the count with your option in your command line. We'll do that later. So here I can see that I ping my address for my system, and I'm successful. I sent 4 and I received. So I have 100% success and 0 loss. So this is one way that you can check to see if a system is connected by pinging its IP address. But I can also ping myself, right? Using a loopback address. So whenever you see the 127.0.0.1, it is a loopback address. It's going to come right back to that system. So it's pinging itself, right? So if I do this, it sends also 4 requests. But now if you see timeout right here, that means that it's disconnected. It's not connected, right? And it will tell you the percentage. So if the system is unstable, it would not be able to reply 100%. Okay, so this is one way that we can check, and ping is always a good command to use. Now, some network administrator, they would disable the ping command. Why? Because someone can flood you with the ping because it keeps sending requests continuously. There are tools that that's a Smurf attack, that there's a tool that we can just dump like 50,000 ping at once to a system, and it gets so busy, it gets bogged down, and that's denied service. Okay. So basically buffer overflow, like what we talked about before. So this is what you see with ping, right? Any question? Okay, so let's pull 6 down to the next page in case we're still recording. All right. So on Windows 10, how do you update network interface card driver? And this could be your interview question. They love asking about troubleshooting, right? Remember what I said, 2 parts, hardware and then software, right? But remember the tasks that you do on hardware level. So when you call tech support and say, I can't connect to the internet, I can't connect to the network, they're gonna go through these steps, right? And then for your certification, they love asking about troubleshooting questions as well. So how do you update your network adapter on Windows 10 or 11? You're going to use Device Manager. Device Manager is a tool that allows you to manage all the hardware components that's on your system. And one of the hardware components is your network adapter, whether it's wireless or it's wired, right? You simply would right-click it and select Update. So how do I get to Device Manager? Just search for it. Opens it up, right? And then go to your network adapter here. My laptop doesn't have an Ethernet port, right? It only uses wireless. So I would then look at my Wi-Fi card, right? But if you look at I don't think you're able to update the driver on the Alienware where you're sitting at, but you should be able to see it at least, right? You would see some of the adapter information. We can simply right click and then choose update driver, or go to properties and then click update driver. Now, I'm going to tell you that Windows is going to try to give you the Windows Microsoft built driver, right? If you search for the driver, it basically pulls the driver that Microsoft is OS came with. but doesn't necessarily be the best. So if you want your actual driver from the manufacturer, you can go to the manufacturer of the motherboard or the adapter, right? If you have a laptop like me, I just simply go to the manufacturer for the laptop, look up the model, and be able to download the chipset driver because it's part of the motherboard on my system. Now, if you buy an adapter and you plug it into your gaming PC, you just simply go to the manufacturer website that sells you the adapter. Okay. And we should try to update the driver in the case that if it's malfunctioning or it's not doing what it should. I normally would do that when I first install OS, right? And install the hardware. Okay. So make sure we know the step on how to do that, because for those of you who are doing apprenticeship, right, they would ask you these type of questions when they interview you, technical questions. Done?
Yeah.
All right, see you later. Okay, so now let's talk about hubs and switches. Okay, so simplex, full duplex, half duplex is on page 3 at the bottom. MAC address right here. And like I mentioned before, right, the OUI, the manufacturer information, is the first 3 bytes of your MAC address. And then, so half of it is going to be about who made it, and then the other half is going to be the unique ID for that component, that adapter. Okay. Troubleshooting. And you can look further, right? It talks about how you can test it. You can use diagnostic program. Sometimes that helps, sometimes it doesn't help. It basically does a series of tests, including a ping test, like what we did, a loopback test, right? That's when you ping with the loopback address. So it does that in the back for you. So when you do diagnostic, just keep in mind that it does run some of the system command in the back. So I talk about update driver, and I want to clarify what driver is because some of you knows this really well, right? Most of you probably do. Some of you are new to the terminology. So driver is just a software that contains instructions for the system to function a certain way, right? To, like, for example, the network adapter to be able to convert everything to bits for transmission. And that works with the operating system. So it is a piece of software that the OS uses to be able to communicate with the hardware, right? But if you take the CIS41 and talk about OS and the different layers on how it uses like a certain area of the OS to be able to manage your hardware. Okay, so let's talk about hubs and repeaters, and then we'll go into switch. So a hub, hub was very popular in the 90s and early 2000s. It looks like a switch. Here's a picture of it. So it doesn't have the capability like the switch. What the hub does is it's basically sends to everybody. So if I connect the 3 system up front to a hub, right? If I want to send data from system 1 to system 3, everybody receives it. So there's a lack of security and it takes up a lot of bandwidth in the network. So when you have larger network, right? Let's say 100 systems and you using hubs to connect. What happened is you have systems that are just broadcasting to everyone and you don't want your data to go to everyone, right? And then the repeater, all that is it takes the signal, duplicates it, and sends it down, right? It repeats that same signal. So some of the device that you see, like your wireless router at home, has a repeater built in, right? But that's different than the amplifier, and I clarified this on Friday. An amplifier takes the signal and increase the power, okay? To have the signal stronger and it sends it. Where you have a repeater, it takes the same signal and sends it down. So if you have a repeater and an amplifier, it takes that signal, strengthen it, heighten it up, and then sends it down. So the repeater, its job is to make sure that that signal is carried in further distance. Where an amplifier, it makes sure that that signal is strong from send to receive, right? So the hub, what it does is it sends it to all. And the way that we connected the hub back in the day is we cascaded. That means that you take one hub, because that's the technology you had. And if you have more system, you have to connect another hub because now I need to plug in the other system. And then you would connect another hub. And the way that you do this is you would take the first hub, right? You connect it at the last port to the next hub on any port, but usually I try the first port and then so on. So on the last port, we would cascade it down to the next hub and then the next hub and so on. That's how we scale out on a segment back in the day. Now the downside of this is if I'm here and I'm trying to send from here, this hub is gonna then send to everybody and it's just pull in a lot of bandwidth. So your network becomes extremely slow when a lot of systems are sending and requesting at the same time. Okay. So to answer the next question, you can refer to that section. So it asks you, how can you connect 3 hubs that consist of 8 ports? That means that I want to be able to have 24 ports or around 24 ports available to my devices, right? So you are going to connect the uplink port, which is port number 8, the last port on the hub, to any port on the second hub. I just like for practice, I just do last to first, last to first. So that way it's easier for me to pinpoint the port when I need to troubleshoot. Now, some people, they just plug it into another port. My advice for you, the more you are organized, right, with how you schematically set up your system, the easier it is when you go in and maintain and fix it. Okay? So you would connect the uplink port 8 from the first one, you cascade it to the second, you connect it to any, but I connect it to the first port, and then take the 8th port, connect it to the next one, and so on. And that's how you would expand, right? So ultimately you would have 3 hubs connected together. Remember, when you're doing devices to devices on Ethernet, you're using crossover, standard A and B. Okay? Now, some device, you can just use regular Ethernet cable, and it will tell you that, right, in the specification. So you have 2 categories of hubs. One is active and one is passive. The passive hubs contains no power source or electrical components. So there's no signal processing or no regeneration of signals. So it doesn't repeat. Okay. So there's no reliability in a passive hub where if it gets there, it gets there. It doesn't matter, right? It cannot regenerate. So if I'm on the hub, I'm system 1 and I need to send to system 5. And if system 5 doesn't receive the data, it cannot regenerate that transmission. Okay. So that's the unreliability in the hub use and for the passive hub. For the active hub, it contains a power source and it has a repeater, right, to be able to extend the signal further, right? So if you have the choice between the two, which one is more reliable? The active hub. It's able to repeat the signal and it will be, so that way you have a little bit more higher in probability of getting the data that you intended to send. And then I talk about the repeater. Basically, you take the signal, right? Some repeater would rebuild it if there's signal loss. And it's going to take that and it's going to send that signal to a further distance. So in a college campus like this, your access point, right, most of them has repeater built in. So that way you would have more, right? More span in your wireless signal for the number of mobile devices that are connecting students, staff, faculty, etc. Right? Now, so you would think about, and some devices come with the repeater. So the repeater take that signal, right, and sends it, repeats it, sends it further. Now, in the case that it's lost, right, let's say that I have degradation in signal, right? Because when you have a lot of appliances together or travel the distance, sometimes your cable can, too many cable together, it can cause, right, data degradation. Or if you have very long distance, you also have signal loss. So what you have to do is some system would be able to rebuild that same signal as it sends down. Now, in my experience, if you ever use wireless repeater, they're 50-50, right? You can try and you can tell me, right? They are not that reliable, but in the case that if you have wired signal, some of them, some industrial systems are a little bit better, as what you see. So if you drive around the city, right, if you're using the city Wi-Fi, you see that these appliances are also repeaters. So it should be placed before the maximum distance, because when you're at the edge of the distance, right, what will happen is you already lost that signal. So we want to go before. So if you're looking at 100 meters as the maximum distance, we want to go 90 or 80, the placement before that, right? To save yourself like a little bit. So, and you want to overlap so that way there's no gap in your signal, okay? A good network engineer is one that understands how to scale without degradation, okay? So. Any question? Okay. Let's move this one up a little so you can see them together. All right. So let's talk about bridging. And I put the comment, I think I got through all your lab one. And then we talked about that last session on your topology, right? As you consider the switches are bridging together. So when we say bridging, meaning that we can connect one switch with another switch, right? And you might have 16 switches or 1600 switches, right? Depending on how big is your network. But ultimately, when you are connecting the devices like switches together, switches especially, they handle MAC addresses, right? The physical address that's ingrained onto the network adapter for the system. So we would use these MAC addresses to be able to connect, right? Switch 1, which is segment 1 of the network, with switch 2, with segment 2 of the network, or switch 20, right? Etc. So as we build out the network, you might have many switches, and as they are connected together, right, you would see that MAC addresses would be able to be implemented in the configuration for your network segment. The address would then be stored, like I mentioned before, right, onto a table. And this table is used by the switch as a reference to see who's connected and who it's connecting to. So if I have switch 1 with switch 2, right, on this table, it's going to say switch 1 is connecting to the address of switch 2, and switch 2 is connecting to switch 1 and switch 3. So the table would then add along with all the client systems that are connected to it. The table is then stored on storage, which is RAM. All your network appliances have RAM. Some of them, some of the security appliance actually has drives, but very rare, right? Now the RAM would then be where the table is found. Okay. So it's very important that you protect this from a security standpoint, right? Not everybody should have access to switch table, right? Because if they wipe out your switch, guess what happens? Disconnection for the whole segment or more. Okay, you're done. You're in trouble. Unavailability is without the A, we only have CI. Okay, we can always use, right, this table to also, earlier Dima said, right, what if we MAC filter? So in security, like CS27 class, we talked about MAC filtering. We can add the MAC address associated with the port onto the table that we allow the system that's connecting. And then we would reject everybody else, right? We will whitelist that. So you can filter via switch level. So why should we use a switch to connect the system compared to a hub or instead of a hub? Because switch is going to give you more reliability in transmission. So in the case that if you have data loss or error in transmission, the switch would be able to retransmit. And you can also control, right, port security with the switch, whereas the hub, you cannot, right? Some hub just sends to everybody, it doesn't care. And then even on the active hub, it just repeats and sends. So the switch, you can pinpoint like which system is connecting physically to which port, and if that's allowed, right? And then also when you're looking at bandwidth consumption with the hubs, if you have many hubs, is actually more because it sends to everybody. It's kind of like every time that I need a system, I tell everybody that I need a system, right? So it's going to take up a lot more network bandwidth. So if you're using a switch, you're able to, number one, streamline with reliability. Two, you're able to save your network bandwidth for the users, the systems that are on it, versus the network communication appliances that's using the majority of it. So if you're looking at something from the 90s compared to our modern time, we definitely have more of an efficient, more efficient network, right? With higher throughput rate if we manage it appropriately. Question? So we have a whole unit on switch and switch configuration. I gotta follow up with the district office to make sure that they're able to send down some switches for us to use. And then, so we'll come back to some of the more detailed concept with the switch, right? So this is kind of like an overview of all the network components and systems. And then we'll dive deeper into switches and VLANs, right? After we get into a little, I give you guys about a couple of weeks on packet tracer. I don't teach my course completely on packet tracer because I found that simulator works for some people and simulators don't work for other people. So you will actually program the switch. And you will find that different models have different commands and different ways. And so you have to overcome those things in the field, okay? Because there's no Dr. Win, and you might have Google and AI to be able to help you, but sometimes they're going to give you the general answer, right? You're going to have to fix things yourself and troubleshoot. Question? Okay. Let's go to the next part, which is about VLANs. So some switch operates at a higher layer. We talked about OSI last week, right? Layer 3 is where it routes. That's a network, right? Layer 4 is where it transports. So if you're using voice over IP, you have to use layer 4 or higher layer switch, multi-layer switch. And with that, you would see that we would be able to have VLAN option. There are, your simple managed switch function at layer 2. Okay. It does have one default VLAN option compared to multi-layer switch where you can create many VLANs. So when we say virtual local area network, what does it really mean? It really means that we would take a group of physical port on the switch and we can group it for the virtual local area network. So for example, I have a 24 port switch. I can take 10 of the port, port 1 through 10, and I would use that to create a VLAN. Okay. For a department like finance. And these are the systems that are connecting to these ports. They might be using specific private data, or they would use different applications. So VLANs can then be set up with IP addresses that would route back inside the network. So we would use VLAN and we would force it to route into or inside the network. Okay. So it treats it like as a separate network. So we can also use VLAN to really reduce some traffic across many switches. Okay. So instead of going across 16 segments, we can force it to only use that physical switch to only use that one switch for that network. Okay. So that would reduce your bandwidth use. Okay. And then you would also have network throughput, which is increase in bandwidth. Now, in VLAN for security, a lot of times we see it as a separation in the network. We can make it where it would easier to manage, control a lot of like the data security and the resources that's used. So VLAN can be important. So I'm going to give you an example, right? So I first came to NBC. I wanted my students to be able to run all the security tools and not be blocked by the district. So I asked them, I said, put me on the dark side of the network, right? So they put, and RCC too, right? So they created these ports, and all of these systems is non-filtered, right? Non-blocked by their network firewall. So you can download most of the things, you can install most of the tools, you can run the stuff on the network without, right? So they simply create a VLAN for RCC and NBC labs like this lab to be able to do that, right? And it's mapping to a physical port that's connecting, so it funnels all your traffic back to those ports. And they can screen it and they can do some stuff with it, but so that way you can have an isolation, you can just play all you want, right? But we can also strictly tighten it as much as we want with a VLAN. Right? For example, if you're looking at DoD, the stuff that, engineering stuff, we can protect it via VLANs. Okay. So let's talk about some of the protocols that you see with the switches. Let me move this down a little bit. Yeah, it would be really frustrating if I'm trying to do a lab and then things don't work because they block it, right? I've had that with other colleges before, and you have to go to bat about that. So, okay. So we're gonna have more additional protocol when we talk about the switch and the routers. There's one chapter on routers and one chapter on switches, but we're gonna talk about some of the basic protocol and we're gonna revisit this, right? So you have spanning tree protocol, your STP. This allows the appliance to be able to create loops, right? So basically loops is coming back to itself, right? And when you're connecting a lot of switches together, loops can cause disruption. It can cause miscommunication. So if I have 20 switches connected together, if they're looping a lot, it takes up a lot of the bandwidth, and likely that you're going to have disruption in communication across the switches. STP is really designed to examine the ports, right? The communication ports for the actual loop. And so it's going to then looking at the blocking state, whether if it's able to pass through or it's coming back to itself. So when it is in a blocking state, then it's going to generate, right? It's going to look at which links is down and it's going to forward it automatically. So it prevent the switches from going down, so that way you have better communication or successful communication when you're connecting the switches together. Okay. That's one benefit for STP. Now, when you are working with switches and VLANs, likely that you would hear the term trunk or trunking with the TR, right? So when this would allow you to have multiple switches connected together, then you're gonna use one of the ports. Let's say I have 24 port switch, I use port 1, right, or port 20 as a trunk port. So you have to configure as a trunk port. Trunk is kind of like an older technology, but you would see that used still in a lot of the switches. And this port is used for VLAN specifically. So you would configure your VLAN and you would set that port to trunk, and it's going to push all the VLAN traffic from the other switches to that port 20 that we specified. Now you can also, right, allow it to contain a list of other ports on multiple switches. So maybe all the member switches that we're connecting. So you have VLAN traffic that's coming through. We do this. Also, we want to be, and I'll talk about port mirroring. We want to monitor through that port. And the reason why they really made it also is if you need to disconnect the VLAN, guess what happens? You just go in and modify the configuration for that port, right? So, but it also allows you to have easier administration. Now, some switch don't support trunking, okay? So don't assume that you can do this on all multi-layer switch. So, and you have to really look at even Cisco technology, right? Especially Cisco technology, different version, different model. So making sure that it supports trunking, then you can set that up. Okay, so let's talk about inter-switch link, your ISL, and your 802.1Q. ISL is Cisco specific. It is owned by Cisco. It is their proprietary protocol. This is used for tagging packets that would be specifically for VLANs. So when we say packets, that means the switch is able to route, right? Packets is really used for routing. So on the older switches, on the VLAN, Cisco technology uses ISL, right, to be able to tag the packets specifically on the VLAN. That's how it's able to see, right, all the VLAN traffic. Now, if you don't use Cisco technology, you would see 802.1Q. This is a standard for VLAN trunking. Most of your switches today uses 802.1Q. So when you read the switch information, right, you would often see if it's able to do trunking, right, 802.1Q. And this would be layer 4, 5, or even 7 switches. So it's able to route and switch. So, okay, let's talk about port mirroring. I know we touched on this in CIS27 in another class. I want to come back to this so now you can understand the network perspective of it, right? So the security perspective is that we would take the port and we would duplicate that information onto another port so we can check the traffic. It's kind of like if you ever travel between San Diego to Mexico, Baja California, yeah, you have to go through Border Patrol, right? Imagine that if I place another border patrol nearby, and whatever that goes through that border patrol is also going through my border patrol location, so that way I can see what's happening, right? So port mirroring is a way that we would use an actual connection port, a physical connection on a switch. We would take the data and we would copy it to another port. For example, port 10 on a switch, right? And I would duplicate that, right, to port 20 on the switch. So whatever goes through port 10, I would see it on port 20. Why don't I just use to go to port 10 and look at it? Well, when you are interrogating the traffic, when you're looking into the port traffic, it requires requests and response. It also consumes time, right? And resources. So what you want is you want to mirror it. You want to take the data, the traffic that was sent to one port and copy it to another port so that way you can monitor it, okay? Without interfering with the existing traffic, okay? So we do this a lot for network monitoring and security reasons. And then the next part, port security and authentication. I think we touched on MAC filtering before, right? We would be able to set up, right, which MAC address is tied to which port. And then we can also specify, right, like if they're allowed to connect. So MAC filter is that. It's called port security. My rule of thumbs, right, whenever I teach this level or even higher level, if you're not using something, turn it off, right? So on a switch, if I have 24 ports and if I'm only using 20, turn off the other port, okay? You just go into the configuration, you disable it, so that way someone walks by and they're trying to plug their system in, they cannot, right? Even if you MAC filter, remember, MAC can be smooth, right? But if you physically turn it off, right? You turn it off in the configuration, there's no link live, it cannot be connected, then you have more security. So then we also have port authentication that will allow you to have increase in security when you only would allow certain system to be connected to the physical port. Like system 1, connect to port 1 on switch 1. Okay, with that particular address. So security is not a one thing solution, right? You have to have multiple things, right? Encompassing your security, overlapping, so that way you have, especially network security, you have more strength in security, right? But there's no 100% secure system or network, right? As you know. So this is why the industry always demands the work and the improvement, which gives you job. So understand network and network security is important for the industry. So that's to think about your career. Okay, let's talk about routing table. Similar to a switch table, the router also retained the record of which router it's connecting to. Remember, I see a lot of topology, servers connected to router. No, router connects to router, okay? Router is like the freeway, the exit. It doesn't get to the road in your house, okay? So the router connects to routers. And a lot of the routers, what it does is it looks for who's available first, or it might look for specific router. I can set a static route, router 1 to router 2 to router 3, or it can dynamically identify the router that's available and sends it. So the routing table is used to store route information. So in the case that it needs to reroute, right? It's capable of doing that quickly. Just think about Google Maps, okay? If you need to get from home to work, and it stores that information. It's gonna give you the same route, or it can look at the fastest way to get there, right? So you have option to go the same way every day, right? That's static route. Or you can say, okay, today I'm gonna take the freeway, but yesterday I took side streets, right? So because of traffic, for example. So the router stores the route information, and it's going to use that to determine how it's able to connect with the adjacent or the neighbor routers. And your internet is made of autonomous system that routes. That's it. Okay. So if we can get from here to Google, right, in Mountain View, California, how so? Well, routers to routers across the network. I think I have. Let's see, 2 hours. Okay. So on a multi-layer switch, and I mentioned this for multiple times today, layer 4 and up, right? So you have a switch that's capable of route, transport, right? It would be able to allow you to have session, all of you even find layer 7 switches these days, right? So that means that it has multi-layer switch, not just at layer 3, but higher. It would also allow you to filter, right, to route, and if you're using voice over IP for your data center or your call center, you would also be able to set that up. Okay. So the service that comes with it and the protocols that's capable of accommodating for your network, right? That comes with the functionality of a multi-layer switch. So when they're saying layers, that pertains to OSI layers. Okay. Like halfway there, so. Sorry, this chapter, this unit is kind of long, a lot of information. So I want to make sure that we get through with ample time so we can do other work as well. Okay. We talked about the multi-layer switch. You can go back to the notes and also read further. I recommend you do that, right? So what kind of devices that you can control collision in the domain? I think we briefly talked about collision. In a network, you are going to have collision regardless. Okay. So we want to be able to manage this so that way we don't have congestion or slowdown in the network. We don't want to have lower performance. So what you can do is you can use a switch to be able to manage your collision domains. Okay. So it would be able to send data to the port where it resides on, which prevents it from the actual collision itself. Now, we talked about collision detection, right? Your CD and and then collision avoidance in the first unit, your CD or your CA. So some technology that comes with that, if it only detects, it only would notify you or keep record that there is collision potentially at specific ports. But if it's able to avoid, then it's able to navigate around that or retransmit into a different port. So it sends the data to the port where it resides on to prevent. So likely that it would be able to avoid collision. Okay, so you would configure this on the switch or enable that option. Now, the network devices that you would use to create a broadcast domain. So when we say broadcast, just like what the term imply in radio or TV, right? You hear broadcast television, broadcast radio. When they broadcast, they tell everybody, right? Everybody hears. So some systems, some part of the domain or the network would be broadcasting. Okay, that means that it tells all the other system about the network. Okay, so you would use a router or a multi-layer switch with the VLAN capability. And these are the devices to create broadcast domains. And you would use specific address, and we'll come back to that in a few weeks. Okay, so I put it all comment. If you put the server here on the router, is that a gateway, right? So earlier you saw my IP address. The .1 represents a gateway. Just like how you leave a mansion, you exit through the gate, or when you enter a mansion, you go through a gate, right? So a gateway really represents the first system, right, that is going to interface your network with the next network, okay? And often we use a router for that, right? At home, you use your wireless router, that's your gateway. So it's a .1, right? 192.168.0.1. That's the first system that someone sees when they enter your network. That's the first, right, doorway that we would enter into your mansion. Okay. So this system ensures that one environment is accessed, right, from coming in from another environment. And because each network is different, it needs to translate, right, information from network A going into network B, right? So that's how we're able to get our networks connected through the gateway. Okay, for 20. The administrator wants to use a network device to monitor network traffic for suspicious behavior. What type of network devices should the administrator use, right? In my opinion, this answer can be multiple, right? But when we narrow it down, it can be an intrusion detection system. An intrusion detection system is an alarm system, right? Just like a fire alarm system, you know how some fire alarm, it only sounds off, right, when the fire breaks out. Now, some fire alarm would sound off and it turn on the sprinkler, okay, to put out the fire. And that's not an IDS, right? Or an active IDS. An IDS simply just sounds off. So it just detects and say, hey, something strange is happening in this part of the network. Now, if you're using a network intrusion detection system, because there's difference, right? There's IDS and there's NIDS. So in a network environment, we would use a network intrusion detection system. We would place it inside the network, so that way, in the case if someone breaks into our network, it would tell us. But in my opinion, NDS is already late, right? It's good to have that extra measure, but by the time that you detect, things already been happening, right? So it's better to be proactive than reactive. So we want to have an IPS, an intrusion prevention system, a network intrusion prevention system, like the fire alarm that sounds off and puts out fire, it turns on the sprinkler. Okay, so that is a better measure. So it snub the attack at the foot of it, and then it protects your network. So if you just want to monitor and detect, IDS is, at the least. Okay, network intrusion detection system, your NIDS. And then there are two different types. You would see an active IDS. So an active IDS is going to give you the activity. So it keeps a record of suspicious activity. Now, the newer modern system is intuitive, meaning that out of the box, you plug it in. You shouldn't just use the default system, right? It should look at your network pattern and it builds, right? And now they have AI integration, so You give it data and it's gonna tell you, oh, this is a custom pattern and it's going to detect based on the health of your network. So it keeps a record of all the irregular activity, right? And it does have some corrective form. Remember what I said about the fire alarm that sounds off and put out fire? So that's an active IDS or an IPS. An IPS does that, an intrusion prevention system. Now the passive IDS, it doesn't take corrective action. It just tells you something is happening, but it doesn't do anything about it, right? It sounds off the alarm and that's it. So normally we would go with the active options, right? But sometimes companies, they're gonna use the technology until they can't, right? Because of cost, because of, updates, etc. So you're gonna have to work with what you have. And this is how you would see that sometimes we don't have a choice in how we want the security solution to be, but we work with the best that we can with what we have. Okay. So to add to your topology from week 1, right, you can throw in an IDS on the switch segment, right? One on each side or one. But the more security appliance that you have, so when I used to teach bachelor student level or even higher, they love to add like so many security appliances because it's better to be safe than sorry, they would tell me. But you have to keep in mind that you have to think about feasibility and the performance, right? If you filter a lot, likely that you're going to slow down the network. You want performance, but you don't want the bog down with it, right? If you're going to filter so many times, yes, it's good to have really good security appliances, but it doesn't always, it shouldn't have to filter so many times and slow down your network. So think about that. Okay. Okay, so IDS is on page 13, right? Active and passive. And then there's a section that goes into wireless. We're going to come back to wireless also in another unit. But it talks about how you can use wireless access points. And wireless access point is different than wireless routers. Some routers act as an access point, but access point sometimes are not routers, right? Because if you throw access point into the switch, right, those are going to be able to allow all the systems to have access mobile wise, but you have to have a router to route. Okay, understand the difference, because at home you use a wireless router that acts as an access point. It's all in one device, but in the industry, you're gonna see AP is not router. You're gonna use an actual physical router. You connect the AP to the switch to the router. Okay. Okay. And then it talks about voice over IP. I highly recommend, if you want to excel in networking, right? Look into VoIP certification. Tons of network jobs that require that. Everybody use phone at the office, right? And you have to understand how to configure voice over IP. And then analog modem for dial-up conversion. We talked about CSU, DSU. Okay, let's get into ISDN. So when I started in the field, after like maybe a few months, I started installing a lot of ISDN. I did a bunch of frame relays too. So it's old technology, right? And ISDN was expensive. Okay. It was the best that people could get for the business. There are different tier in ISDN. So we went from a dial-up, which is telephone analog, into, integrating, modem and then eventually cable. So what you see is you have to configure some of the ISDN, and somewhere in the world today, you do see ISDN still. They keep it as a backup line. But back in the day, the way that they use it is you install these lines or where your router and switches is kind of like fiber line now for us to interconnect with the service provider network. And they would charge you based on your data rate, right? Or connection time. So you can pay for the, you know how like mobile service package, you can pay for how much data that you can download, right? It's very similar to that. How much data are you using on your network or how much time that you're on that line? And then eventually we moved away from that. So there are two categories of two types. One is BRI. You see this on A+, you see it on Network Plus, you hear it again on Security Plus, right? Old technology, but you have to understand it. So the basic rate interface of BRI, it uses 128 kilobit per second. So it's made up of two channels. So it's a double channel of 64. So if you take 64 kilobit per second, you multiply that by 2, you're going to get 128. So when you configure, you're going to have to configure 2 B channels and 1 D as in David channel. And the D channel is mostly for control, right, of the other 2. So that means that if I'm using BRI, my transfer rate is only going to be max at 128 kilobit per second. So when we say max, it's going to be roughly around there or lower. Now, if you pay a little bit more, you can get a primary rate interface, which is your PRI. And this is going to be 1.5 megabit per second. And this is a lot for back in the day, right? So what it is you are going to take 23 of 64 kilobit per second channel, the B channel, and you group them together. So 23 times 64 kilobit per second is going to give you roughly 1.55 megabit per second. And you're going to use 1 D channel at 64 kilobit per second for signaling and control. Okay. And then we'll come back to the tier and all of that good stuff also down the line. But you do see this on some certification, they ask you about this. So know the difference, BRI is slower, right? It's made up of less channels. PRI with the P is faster. More channels grouped together, right? So you have higher throughput. Okay. So the goal in networking is to make sure that you have network performance, right? Your network in security, we talked about the 7 nines. It has to be available 99.999%, right? That means that it has to be up for most parts. And then your network has to have high throughput, meaning that your rate has to be consistent in your transfer. So if you're fiber, you need a transfer at fiber. Your user needs to be able to have quick response, right, when they're connecting and so on, right? That's to mesh. So with that, we need to make sure that we have the appliance that would allow us to have the performance. One of the things, and if you interview for a networking job, they're going to ask you, right? How do you achieve quality of service? What is a network balancer? Okay. And if you talk to administrator, people who maintain the network, they talk about load balancer. So a load balancer is a system, a network system that allows you to split the workload, right, across multiple systems, multiple servers. It would help improve performance because you're not bogged down to one single system to do the job. So let's say that I told you to go and do something very difficult, right? But instead of tackling it yourself, that's going to take you 5 hours to do that. You're going to give it to 10 people at home, right? One tackling that. And so you're able to finish everything in 10 minutes. The load balancer does that. It takes your traffic, heavy traffic, and it distributes it to multiple systems. You have to configure it, right? So that way it would send it across and the system would then transmit it. Okay. So that way you're able to have faster response, right, for that instance, that moment in time for that particular workload, that request. And this is how we handle distributed denial of service these days, right? Instead of, because when they attack, they're gonna attack that one system. So if you take it and disperse it, right, you're not holding that system bogged down. So now we can divert the traffic. So as soon as your firewall, right, sees it, or your system, your IDS sees it, then what we do is we can configure it so that way it disperses it. So when you load balance, simply you just giving it out to the other system to also handle concurrently, so that way you can have better response. Okay. So let's talk about proxy. This is something that I added also into your comments sometime, right? And I know that if you had me before, I talked about proxy, but just to review or provide you the definition. So a proxy server is simply a network device or a system. You can use it to really handle internet requests like web pages, right? You can also use it to manage your traffic. You ever deal with constructions, right? You see that sometime you would have a person that holds a stop sign and one side go and one the other, right? And the other one stop. So a proxy can be used as a traffic cop like that. Somebody that holds a stop sign for one side, the other side go, and then they turn around, they hold stop on this side, and then the other side goes, right? So a proxy can be used many ways, but in school district, proxy can be used to prevent students from accessing specific websites if they don't want, right? But proxy can also work with load balancer to be able to diversify the traffic. So for example, I can use a proxy to regulate the traffic where high priority traffic, for example, Amazon, their priority is to retail things online, right? So customer requests coming in, that's priority for Amazon. Everything else like inventory and all of that is also secondary and then third, right? So if you take the priority traffic, you're gonna manage it with certain proxy and delegate that, right? This side only goes and it goes this way. And then I'm gonna give you less priority traffic. I'm gonna delegate that and load balance it out to other systems that handles. And you see this in network performance for business, and you have to manage it appropriately. So that way you have more of a successful network, right? Okay. Almost there. And it continues. Okay, I'm gonna move load balancer down to the next page so we can see the rest. Any question regarding some of these appliances and role? I know some of this is new, right? We will get more used to the terminology and the functionality of it. Okay, so let's talk about virtualization. Virtualization is it, and the cloud is it for this industry. It won't go away for a long time. I remember when I attended Dell and VMware show when they first, like, they took us to a safe house, they sat us down, they said, oh, this is the type of technology we're gonna sell. You buy the server, I sell the software, you can use it, right? Everybody, if you want to really get into more of the administration, a few areas that you can get certification in. Get Azure certification, which is cloud, right? And with that, you should also get Hyper-V for Microsoft. Everybody uses Microsoft these days, right? Bill. You can also go the VMware route, get certified in vSphere or their server administration, and I guarantee you're gonna be hot stuff, right? I was certified in vSphere area for the older versions, right? And people still recruit me, even though I turn my LinkedIn off. So once in a while, I get a recruiter asking, "Hey, do you wanna?" I had us off. They offered me a contract with Apple one time for 9 months. But you know, so the more skill sets that you have related to virtualization and cloud, the better, because it's here to stay. Okay, so let's talk about virtualization. In security, we use it for testing, right? In the current network you're sitting at, you saw the server information earlier, it is virtualized. Okay, it's a way to save money, and they would rent space on the cloud to create an instance. So for example, I pay for the AWS or Azure. I would use these virtual machines to run my server roles like authentication, web, right? Hosting a domain, for student applications, file, all of those things can be ran from a virtual machine. Okay, and you can remotely connect to it to manage it, right? Or I can have my user connect, using thin client to the virtualization technology. So for hypervisor, if you're using Microsoft Hyper-V or vSphere for VMware, and then they have other technology, that will be type 1. And for type 1, it simply uses their software, Hyper-V, right, and run directly onto the hardware on the host OS of the parent virtual machine. This allows the hypervisor, so when we say hypervisor, that's the virtualized software, to control access to all hardware on the guest system. So if I use Hyper-V, I don't need to buy Alienware system. I can buy a very small computer, which is what you will see at the makerspace, like a tiny machine that's attached to the monitor, and I can push all the virtualized image from the server. So whenever Patricia logs in, right, she's gonna get her own desktop from her virtual machine, right? Or when Dre logs in, he's gonna have his own custom desktop, and it's pulling it from the actual server, which access the hardware directly, right? So those instances can also be clouded, so it's just running from a remote server. And this is what you see in parallel. So whenever you see cloud, likely that there's an instance or a virtual machine that is used with the cloud. Now, when you're doing your virtual machine in Dr. Wynn's lab, you're using Hypervisor 2, which uses a host computer with an OS, and we install VirtualBox with it, right? So when you're using a separate software for the virtual machine, like VirtualBox or QEMU, you are actually using Hypervisor 2 for virtualization. Okay. Okay, so virtualization, you can see that on page 16, right? It talks about this. Type 1 and type 2, VirtualBox, right? Or if you use VMware Workstation, QEMU, those type, that is what you see with the normal workstation to run virtual machine. That's Hypervisor 2. And then you have other appliances. So you can have virtual firewall, virtual routers. Sonic Wall is a form of virtual firewall that they'll use, right? Not necessarily just software, but you can set it up as a virtual machine type of systems to be able to filter. And you can also have virtual NIT. So when you're using your virtual machine, it actually creates a network adapter that's not real, right? It is a virtual network adapter. And so when you look at that today, right, think about the virtual network adapter, and so on. Okay. All right, cloud computing. You hear this repeatedly across all books, right? So you have different options for the cloud, right? There's different model. You have the public cloud, which is what you see, where you don't have to pay a monthly subscription, and you should be able to use like your Google Drive. Then you have a private cloud where you can actually pay, and sometimes you see this with business. and then you have a hybrid, and then you have a community. So a community is a way that organization can share, right, which is for 26, can share the cloud model. So for example, I'm a small business. I can't afford to have all the cloud, right, service, right? I would partner up with another small business close by or in the same building, and we would be able to share the resources this way. All that is to lease, right, a rack space, so that way you can store things or you can host things. It's kind of like, you know how when you have a lot of stuff at home and you don't know where to put it, you go and you have a rent a storage, right? It's a space where you put your stuff there and you lock it up, right? So renting a cloud is like that. It's a way that we can actually rent system space for the type of service that we need. Some would be infrastructure, IaaS. Some would just be for software, right? Application. Some would be for other things, for function. Now they have a lot of different things for robotics needs. So community cloud is a way that companies can share cloud space. And so when you are using cloud, these are the things that you need. And why do we talk about this? Because cloud is a lease network that will be part of our network. The first thing that you have to consider is connection to it, right? I used to look at security plan of people and they would say, oh, you know what, my backup plan is to have everything, you know, put as backup system on a cloud that I would rent with AWS or Azure. Well, that's if you don't have a storm or a fire that wipes out your landline, right, your fiber line or your internet connection line, and you're still able to pull your data from a remote server somewhere. Right, so you have to think about, oh, maybe I should get a satellite connection or something that is, so reliable internet connection is the first thing you need to think about. You need to also have security policy for data access based on regulations between the local and the cloud storage. TikTok is dealing with this right now, right? Because you see that if the data is housed in a geographical location, it is going to be pertaining to that regulation. So if it's housed in China, right, they might have more or less restriction in how secure is the data access. So we're, our government is saying that, well, it's housed in different part of the world. How do we know that your data, your video, all your information is secure, right? So you have to really consider that. And also when you're buying cloud, the farther you are geographically to that data center, the more you're going to pay to the connection and fees and some of that. So you do see, and if you get AWS, there's east, west, and some area that you can access. You don't want to go beyond that because just like everything else, connection to the farther distance is also going to include charges. And this part, I would refer to the notes if you want to go back to the note pages and, because it's very lengthy, but I'm going to sum it up for you. Some of the storage connections. So data is the most costly area in the network, right? Everybody has a lot of data. And with the current AI, this is what we use, right? Data, you got to feed it data in order for it to behave a certain way, or you can have a model and train it a certain way. So we, if you talk to all admin, data is, storage is expensive, okay, regardless. Drives and maintaining it and making sure, because everybody stores a lot of data. So you can go network attached storage, right? Or using SAN. And when you're using SAN, some of the SAN equipment, typical SAN, you would have to buy fiber channel switches. These are specialized switches that you would use to implement with SAN for storage. And that would allow your user or your systems to be able to access data in a quicker manner through the network. And it would integrate fiber channel interfaces using fiber cable, using fiber channel switches, okay? And sand is costly. If you talk to anybody, and even if you look at the price, it is expensive. Okay. Now, SCSI, so SCSI, the way you say it is SCSI. iSCSI is a protocol that encapsulates originated from SCSI technology. Okay. And so this is going to allow us to handle IP packet command using Ethernet instead of fiber. And so if you are having storage devices or servers or even remote storage, right, say in the cloud, we can also integrate iSCSI to our technology or use the technology that is provided with iSCSI feature that allows you to connect Ethernet. Okay. Yeah, Broadcom was saying that it's Ethernet all the way, right? And 80, because I just lectured to you guys on Monday. I went there on Wednesday, and they were talking about 802.3 all day long, right? So I don't think even with AI, but they're using ultra Ethernet, so it's able to have higher bandwidth, higher rate. And then a fiber channel over Ethernet, FCOE. This is also a form of fiber channel that uses Ethernet frames, so you're able to adapt fiber to Ethernet network, right? And it's still going to give you high-speed network storage. So you want high speed, and then if you are running AI, you want ultra high speed, and that costs more money, right? Different appliances, higher throughput. So all of these things are options with your network storage. And then InfiniBand, this is newer, right? It's also it's based on fiber channel and Ethernet, and that allows you to have the interconnection of components. Okay, so after the cloud, you would see, so there's difference between NAS and SAN. Okay, I know it's confusing because when I first learned it, long ago, I was like, why can't they just name it something else instead of reverse the letter? Come on, right? So network attached storage, this is more common. So this is just a device for file storage, and you can sometimes see it as a computer, a small computer. Sometimes it's a drive with an interface that allows you to do that. I have, if you want like media server or stuff that sync when you automatically connect to your wireless network, you can find an NAS device for a few $100s, and that will be good. This is the expensive one right here, SAN, right? So it's dedicated network that's centralized for storage, so it's more than just one system, right? And then it would have a group of drives, and usually now we use this SSD for fast IO. So, and then connection is also a high cost. Okay, so that's where you can find the information going back to the notes, and it's on page 20. So let's talk about jumbo frame. You have to go. Okay. So for jumbo frame, simply jumbo frame is used to reduce overhead when you send lots of large data. So for streaming company like Twitch, for a lot of the larger media-based company, you're gonna see that a big bulk of their data, especially when you're dealing with audio and video, even in a compressed format, it's very large, right? So if you're having these servers and you're managing communications, or even companies like Zoom for interconferences and stuff like that, right? You see that there's a large amount of data that's being sent back and forth. So the way that they came up with is, instead of using a frame size that is smaller, what we can do is we can use a jumbo frame, right? So instead of 9,000 So we can have it to send one that's 9,000 bytes instead of a smaller size, right? And or instead of having 6 frames. So when you're sending many frames, right, a frame contains data header and data information. So if I have a very large file that's broken up into many frames, right, pieces, remember what I said, right, raw data is in chunks. So instead of having it multiple, what they can do is they can have one big bulk, which is going to be 9,000 bytes. And or we can go all the way up to 1,500 bytes. So that allows you to send it as a bigger chunk. So that way it can pass through quicker. It's kind of like, oh, instead of packaging it into the 6 standard smaller boxes, we can put it in a larger box, right? That is more standardized to our system and send it through. It's still gonna kind of slow it down, but it won't be slowing down too much. So we can chunk it, we can group up the 6 into the larger byte sizing. It's called jumbo frame. Okay, last few, and then we'll take a little break, and then we'll do the lab, and then I will give you time for cabling, I hope. Okay. Any question? All right. Data. I'm sure some of you heard this in 27 in another class for security. We talked about this, especially from a security perspective, because it's a system that has flaws and it's used to control a lot of things. So SCADA system is an industrial control system. It's used to manage, monitor equipment from things like air conditioning across all the buildings, right? Or all the warehouses lighting, right? Like I want to have a system that turns on 16 warehouses light instead of manually going through each one and turn it on. Does it make sense? If you deal with like distribution center that has refrigeration, like freezers, temperature control, SCADA system is in charge of that. Manufacturing floor, right? All the equipment, even though some of the robotics automated ones, right? Now, SCADA system's been around for a long time, and it has its issues, right? So it's basically a system that we use to manage equipment, warehouses, etc. Right? Now the security side is you need to make sure that you update these or upgrade them. Otherwise, somebody gets a hold of this. Imagine, right? You run a manufacturing plant and they turn things off, right? And you're done. Okay. So in industrial automation and industrial type of security, we think about that. Okay. The system that consists of network that optimize voice, video, web pages, or other media to give you the rich media to the users. Those are called media nets, right? You often see these for like streaming companies, company that provides either the service or content, etc. And then the last few is we're going to touch on cabling. So why should you use plenum grade cable between the floor and the ceiling? So when you look up here, that's a fault ceiling. Between the fault ceiling and the regular ceiling are all your cables. The reason why they do this so that way 2 things, right? Hazardous and also, for easy to look at. We don't want a bunch of things hanging, and someone can cut the cable, right? That's the easiest physical attack. Is if I don't want that part of the network, I just cut it. So you want to use plenum grade cable for a few things, because when you have a lot of cable together, they are hot, okay? And they can catch on fire, right? Things can melt, things like that. So they would have plenum grade cable to make sure that you don't have, hazards like fire. But they also, so we want to avoid toxin, because the regular cable, you're gonna have polyvinyl chloride substance in the code, and they do that for retardant and other things, right? In the case of fire. So basically it prevents fire. So in a data center, you often see that they have a false floor. So you have a physical floor and then they have a raised floor and they would run the cable underneath, right? If they don't use a fault ceiling. A lot of time we don't use a fault ceiling is because it's easier to catch fire with the ceiling compared to the floor. And then you can also regulate temperature better with the floor. Right? So if you ask most people who design network, and that's also my personal opinion as well, right? So if I was to pull everything out, race floor is probably more of my direction than a fault ceiling. But you would see that they're used there. And then I will bring in the patch panel. They were in here and then they got brought out because of the room restriction that we have. So you would have patch panel. When you look, the front of it looks like a bunch of ports, like the switch, but it has to open so that way you can connect the individual wire. Remember that you untwist them for the Ethernet. So you can connect them into the actual network panel. And it asks you what is used for the MDF and which one is used for the IDF. So you would use the horizontal cross connect. The HCC cable would be used to connect directly into the patch panel, right? And that patch panel will connect to your main rack. And then the vertical cross connector VCC cable would then be connected to the MDF and the IDF. So I think there should be also pictures that you can find. So plenum is here on page 22, right? And then patch panel is following that. And it talks about your MDF. So main distribution frame, which is the MDF, and an intermediate distribution frame. So the MDF connects to other panels. So you interconnect the panel and then the intermediate connect to the workstation. So from here to distribute to your system, right, you would use the IDF and you would use the VCC for that, your vertical cross. I don't have a lab. Maybe I will consider that for future classes. But I did work for an institution that the students are required to not just make the cable. You guys thought, oh, making the cable was kind of difficult, right? You have to integrate it with the patch panel. I did have some patch panel. So maybe next week I'll bring them in so you can take a look at them so you can see what they're like, right? But I won't require you to do that. But if you are gonna be the one that's setting up the network, right? Like from ground up, you are gonna have to install patch panel. I'm sure you can find a lot of YouTube video on how to do that these days too. So, and then last question, the type of labels that you use. So like I said before at the beginning, right? The IT and security, the more, and even in programming software engineering, I tell my programming students, it's really important that you understand organization and logic, okay? You should organize based on logical things, okay? So we would label, right? When you install, think about a schematic way that you can troubleshoot. Segment should be color coded and you label the port and the cable. So that way when you don't have to run all the cable, you can just go to the port and you say, oh, that's system 24, right, at this location. So you would know. So you need to label port, system, circuit, and patch panel. And if you think about it, right, it's gonna really span out to the larger network. But so that's what I suggest. Okay. And the same thing in security. The more logical and organized you are to start, the easier it is to kind of fix some of the problems when you trace your step back. Okay, any question? Right, let's stop.